An AI isn't born knowing things. It learns everything it knows from whatever data it was fed, which means the data's flaws become the AI's flaws. Think of training data like a textbook. If the textbook only covers half the subject, the student only learns half the subject, and they don't even know what they're missing. When engineers build an AI model, they collect a massive pile of examples, images, text, audio, whatever fits the job. The model studies those examples and figures out patterns. That's it. That's the whole trick. The catch is that the model can only learn what's actually in the data. It has no way to reach outside the dataset and fill in gaps on its own. A classic example is image recognition. Early facial recognition systems were trained mostly on photos of lighter-skinned faces. So when those systems saw darker-skinned faces, they made more mistakes. Not because of any deliberate choice, but because the training data didn't represent everyone equally. This is called a distribution problem. If 90% of your examples belong to one group, the model gets very good at that group and much worse at everything else. Quality matters just as much as quantity. 1,000,000 bad examples can teach a model worse habits than 10,000 clean, carefully checked ones. A lot of modern AI is trained on text scraped from the internet. The internet is enormous, which sounds great, but it also contains misinformation, outdated facts, and plenty of content that reflect social prejudices. The model absorbs all of it. Labeling is another place things can go wrong. If human annotators disagree on what counts as, say, a harmful comment, the labels in the dataset get inconsistent, and the model learns that inconsistency as if it were a rule. There's also the problem of what researchers call underrepresentation. Rare events, minority languages, unusual medical conditions. If they barely show up in the data, the model treats them as nearly invisible. Some teams try to fix this by deliberately rebalancing their datasets, adding more examples of underrepresented groups, or removing excess examples from overrepresented ones. It helps, but it's genuinely hard to get right. The takeaway is pretty simple. An AI model is a reflection of its training data. Better data doesn't guarantee a perfect model, but worse data almost guarantees a flawed one. So when you hear that an AI system behaved unexpectedly or unfairly, one of the first questions worth asking is, what was it trained on? And who decided what went in? If you want to dig deeper, look into how researchers audit datasets for bias. It's a genuinely interesting corner of AI development that doesn't get nearly enough attention.